Today's problem is minimum days to make M bouquets. This is very much like um, the last few problems that we've done, in that it involves a binary search over an answer space. So difficulty is medium. You have a row of flowers where each flower blooms after a specific day. The array ARR represents the blooming schedule. Array at I is the day the flower at position I will bloom. To create a bouquet, you need to collect K adjacent, that's important. You need to collect K adjacent bloomed flowers. Each flower can only be used in one bouquet. And your goal is to find the minimum number of days required to make exactly M bouquets. If it's not possible to make M bouquets with the given arrangement, return -1. All right. Well, let's see. 2 bouquet. Let's take a look at this. Okay. Constraints. Array size and K. Or remind myself, what is K? What is K? K is the number of flowers per bouquet. All right, so K and the size of the array will be between 1 and 10 to the 5th. M, the number of bouquets, will be between 1 and 10 to the 5th, which is 100,000. And the, wow. The element in array will be somewhere between 1 and a billion. We've got flowers that take a billion days to bloom. All right. Expected complexities, there's going to be a log something here, log of max array I. That is the binary. That is the binary system. Well, actually, a lot of companies like this question. I've actually heard of all of these. Topic tags, binary search, right? Okay. Well, let's see. 3 and 2. Okay. Actually, we'll walk through that one as an example. And now this one, day 5. No, I'm sorry. We need 2 bouquets. Each should have 3 flowers. After day 5. Okay, this is not going to work at anything less than 10 because we need 2 bouquets, 3 flowers. That's a total of 6. And they have to be adjacent. So there is no way to make 2 bouquets of 3 adjacent flowers without using this 10. So we're going to have to wait till day 10. This one is impossible. That is an edge case that we'll check for. We want 3 bouquets, 2 flowers. That needs 6 flowers, but we only have 5 flowers. So that isn't going to work. All right, let's kind of walk through this. I don't know if we need to do it in great detail. It's very similar to other problems that we've done. First thing is we'll check for the edge case, the impossibility check, which is the array length less than m times k. Now we're casting that to a long because where are the constraints here? The array size. So k can be up to 10 to the 5th. M can also be up to 10 to the 5th. Now 10 to the 5th times 10 to the 5th is 10 to the 10th. That isn't going to fit in an int. So we have to cast it to a long. But if, in any case, if the array length is not equal or greater than m times k, we can't do it. So return -1. We will get the, we got to define the search range. So the search range is going to be, the low will be the smallest element in the array. The high will be the highest element in the array. Actually, as I've been posting these on LinkedIn, one person in particular has posted answers using streams, which they're good answers. As I mentioned to him, I used Java for so long before streams were a thing that they're just not the first thing that I think of. But they are handy for this. So here we're using streams today. It's kind of a functional method for getting the low and high from an array. All right, that's our search range. Initialize low, initialize high, calculate mid. And then we have a helper function, as we always do in these cases. Now the helper function, if our helper function in this case is called can make bouquets. Now if can make bouquets, it checks to see, and what we send it is the array, the number of bouquets, the number of flowers in each bouquet, and what we are trying out as the answer, which is the midpoint. Okay, is it possible to make m bouquets of k flowers by this day, mid? If it is, then we save it here. Min days equals mid. Now that doesn't mean that it's the best possible answer. It's a possible answer, but there may be a smaller answer. So what we do is we keep the search going, but we move the high pointer down to mid -1. Now, if can make bouquets returns false, then mid is too small. So we have to move the low pointer up to mid +1. Why is that like that? Okay, that's better. So let's take a look at how can make bouquets works. All right, we've got an array, we've got the number of bouquets, number of flowers per array, and the day that we're trying to work with. Initially, we have a bouquet count of 0 and a flower count for the current bouquet, since there is no current bouquet, of 0. Now we'll go through each, and actually let's do this. Let me get a pen. We can just sketch out a couple of things here. You know what? I don't want that one. I want this one. All right. So let's do this example here, and our range initially is min will be 2. Max will be 13, right? Yes. Mid is 13 minus 2, 11, divided by 2 is 5, and then add that to min. So mid is 7. Okay? That isn't going to work, but let's look at why it's not going to work. We're going to go through here and take every day in the array and see if we can use it. Now these first two, because they are less than or equal to the current day, they have bloomed, and we can use those. And k is 2 here, by the way. K is 2. M, which is out of the screen right now, but it's 3. We need 3 bouquets of 2 flowers. So we can use those. We will increment flowers in current bouquet twice. When it gets to 2, we'll increment the bouquet count. So now we have We have one bouquet available. We'll go to we'll go through the next 2 days. Those have also bloomed since they are less than or equal to 7. Increment the flowers current bouquet, 2 will equal 2, and then we will have 2 bouquets. Now we have a problem because this is too big. It hasn't bloomed yet. This, too big, hasn't bloomed yet. There's no way to make that 3rd bouquet. So this is going to return false, right? Let me erase everything over here. Erase. Yeah, I can erase that. So when it returns false, we're going to have to move the low pointer up. So low will be mid plus 1. Oh, I put min and max there, didn't I? Okay. That's actually low and high. Mid is going to become mid plus 1, which is 8. All right. Erase that. 8. Now we're going to get a new midpoint. We'll get 13 minus 8 is 5. Divided by 2 is 2. And mid is going to be 10. I'm just going to cross that and say we're going to try for 10. Now 10 will work. 10 will work because we can go through here and we can take the first two days and we can make a bouquet. We can take the second 2 and we can make a bouquet. We can go here. This one, we can't use it, okay? But these next 2 days, because they are less than or equal to 10, we can make that 3rd bouquet. So this is going to return true. And can I scroll this a little bit? Yeah, I'll scroll it back. But because this returned true, mid, we're going to save that in min days, right, as 10. Because that is a possible answer. But we're going to keep going, and we're going to set high to mid minus 1. So let me scroll it back. All right, mid minus 1. All right, so that means that the high is now going to be 9. If we calculate the mid for 8 and 9, it's going to be 9 minus 8, which is 1 divided by 2, is 0. And that's the min, and it's 8. So what we are going to try now for the mid is 8. And 8 is actually the correct answer. Can I scroll this over a little bit and see it? Yeah, there it is. The correct answer is 8. Because what is going to happen after this round is that the pointers are going to the low and high pointers are going to cross, and we're going to be done. Mid is going to be 8. But again, you can see that we can make 3 bouquets with 8. These first 2 will work. The next 2 will work. Now we have 2 bouquets. That is not going to work. But with 8, yes, we can get the 3rd bouquet. All right. So it returns 8. Let me get rid of the annotations here. This works in the same way that a number of the other problems work, in that we figure out what is the answer space that we're working with. We're not binary searching to find a particular value, but we are binary searching over an answer space, and then for each possible answer we have a helper function to tell us whether or not that answer is a workable answer. Okay, and we keep going, and it converges on the best answer. So let's try, well, actually, let's first of all go back to this. Let's try a quick sanity check on this. All right, that's good. Let's submit. All right, and we are good. Okay. What did we learn? Well, again, it's just kind of a variation on a theme where we, as I said, we figure out the answers, the range of the answer space, and do a binary search over that. These kind of problems need a helper function to take some candidate, in this case, some minimum number of days, and say whether or not it'll work. Now, we tried it with 10, fed that into the function, and the function said, yeah, 10 will work, but then you keep going to see if you can improve on it, and we try 8, 8 will work, and that's it. So, please go ahead and like the video. You can subscribe to the channel for free. You will get problems of the day in your inbox every day. And we'll see you next time.